Welcome to the future. AI is predicting everything. Artificial intelligence, or AI, is rapidly changing the world around us. From self-driving cars to personalized medicine, AI is making our lives easier and more efficient. One of the most exciting applications of AI is in the field of predictive analytics. Predictive analytics uses data, statistical algorithms, and machine learning techniques to identify the likelihood of future outcomes. In simpler terms, AI can use past data to make educated guesses about what might happen in the future. This ability to predict the future has enormous potential in various industries. Businesses can use AI to forecast sales, optimize inventory, and personalize customer experiences. Healthcare providers can leverage AI to predict patient readmissions, identify potential outbreaks, and develop new treatments. The possibilities are truly endless, and AI is poised to revolutionize the way we live, work, and interact with the world around us. Unlocking AI's secrets, it's all about the equations. At its core, AI relies on mathematical equations to make predictions. These equations might seem complex at first, but they are based on relatively simple concepts that anyone can understand. One of the key ideas behind AI is that patterns in data can be used to predict future outcomes. For example, if we have data on the price of a stock over time, we can use that data to train an AI model to predict the stock's future price. The AI model learns these patterns by analyzing the data and adjusting its internal parameters until it can accurately predict the outcome. This process is called training, and it's what gives AI its predictive power. Once the AI model is trained, we can use it to make predictions on new data that it has never seen before. The accuracy of these predictions depends on the quality of the data, the complexity of the model, and the skill of the AI engineer who built it. Neurons and networks, the building blocks of AI. To understand how AI makes predictions, it's helpful to understand the basic building blocks of AI neurons and networks. Neurons are like tiny calculators that process information. Each neuron receives input from other neurons, performs a simple calculation, and then passes the output to other neurons in the network. A neural network is a collection of interconnected neurons organized in layers. The input layer receives the data, the hidden layers process the data, and the output layer produces the prediction. The connections between neurons have weights, which determine the strength of the connection. During training, the AI model adjusts these weights to improve its accuracy. Linear regression, predicting the future with a straight line. Linear regression is one of the simplest and most widely used algorithms in AI. It's used to predict a continuous output variable based on one or more input variables. Imagine you want to predict a house's price based on its size. You could use linear regression to create a model that represents the relationship between house size, which is the input variable, and price, which is the output variable. The model would be a straight line that best fits the data points on a graph, where the x-axis represents house size and the y-axis represents price. The equation for a straight line is y equals mx plus c, where m is the slope of the line and c is the y-intercept. In linear regression, the AI model learns the values of m and c that minimize the difference between the predicted prices and the actual prices in the training data. Section 5. Logistic regression, making sense of yes/no questions. Logistic regression is another powerful algorithm used for classification tasks, where the goal is to predict a categorical output variable. This variable typically represents a yes or no, or true or false outcome. For example, imagine you want to predict whether a customer will click on an online ad based on their browsing history and demographics. You could use logistic regression to create a model that estimates the probability of a customer clicking on the ad. Unlike linear regression, which outputs a continuous value, logistic regression outputs a probability score between 0 and 1. This score represents the likelihood of the positive outcome, like clicking on the ad. Logistic regression uses a sigmoid function to transform the linear equation into a probability score. Section 6. Activation functions, adding a spark of intelligence. Activation functions are a crucial component of neural networks. They introduce non-linearity into the model, allowing it to learn complex patterns and relationships in the data. Without activation functions, neural networks would simply be linear models, limiting their ability to solve complex problems. Activation functions allow neural networks to learn nonlinear relationships, such as curves and decision boundaries. There are various types of activation functions, each with its own characteristics and strengths. Some common activation functions include sigmoid outputs of value between 0 and 1, commonly used in the output layer for binary classification. ReLU, or rectified linear unit outputs. The input, if it's positive, otherwise outputs 0, widely used in hidden layers for its computational efficiency. TAN, or hyperbolic tangent, outputs a value between -1 and 1, often used in hidden layers for its zero-centered output. The choice of activation function depends on the specific problem and the characteristics of the data. Section 7. Data quality matters, garbage in, garbage out. The accuracy of AI predictions heavily relies on the quality of the data used to train the models. If the data is inaccurate, incomplete, or biased, the AI model will learn from these flaws, leading to unreliable predictions. This concept is often summarized as garbage in, garbage out. In other words, if you train an AI model on bad data, you'll get bad predictions. Data pre-processing is a crucial step in the AI pipeline. It involves cleaning, transforming, and preparing the data for use in training AI models. This step ensures that the data is consistent, accurate, and relevant to the problem. Data pre-processing techniques include data cleaning, identifying and correcting errors, inconsistencies, and missing values in the data. Data transformation, converting data into a suitable format for the AI model, such as scaling numerical features or encoding categorical variables. Feature selection. Selecting the most relevant features that contribute to the prediction task, reducing noise and improving model performance. Section 8. AI in action. Real-world examples of predictive power. AI is already being used in various industries to make accurate predictions, revolutionizing how businesses operate and how we live our lives. Here are a few examples. Finance. AI can predict stock prices, assess credit risk, and detect fraudulent transactions, helping financial institutions make better decisions and manage risk effectively. Healthcare. AI can predict patient readmissions, identify potential outbreaks, and personalize treatment plans, improving patient outcomes and reducing healthcare costs. Marketing. AI can personalize customer experiences, target ads more effectively, and optimize pricing strategies, leading to increased sales and customer satisfaction. Transportation. AI powers self-driving cars, optimizes traffic flow, and predicts potential accidents, making transportation safer and more efficient. These examples highlight the transformative potential of AI in improving various aspects of our lives. Section 9. The future of prediction. AI is just getting started. The field of AI is rapidly evolving, and the future of prediction looks incredibly promising. As AI algorithms become more sophisticated and data becomes more abundant, we can expect even more accurate and impactful predictions in the years to come. AI is poised to revolutionize various industries, from healthcare and finance to transportation and entertainment. It has the potential to solve some of the world's most pressing challenges, such as disease prevention, climate change mitigation, and poverty reduction. However, it's important to remember that AI is a tool, and like any tool, it can be used for good or bad. As AI becomes more powerful, it's crucial to ensure that it's developed and used responsibly and ethically. By embracing the potential of AI while being mindful of its limitations and potential risks, we can create a future where AI benefits everyone.